For most of human history, the night sky felt permanent. The stars remained fixed. The planets wandered in predictable paths. Comets appeared briefly, dazzling civilizations before vanishing once again into darkness. But everything we had ever seen shared one thing in common. It belonged here. Born from the same cosmic neighborhood. Forged inside the same ancient disk of gas and dust that gave rise to Earth, the planets, and the Sun itself. At least, that was the assumption. Then humanity discovered something extraordinary. Objects arriving from somewhere else. Travelers not born inside our solar system. Messengers from distant stars. Interstellar visitors. For centuries, astronomers imagined they might exist. Fragments thrown outward during violent planetary formation. Frozen debris wandering endlessly between suns. But imagination became reality only recently. In 2017, scientists spotted something unprecedented. A mysterious object racing through the solar system at impossible speed. It arrived from deep interstellar space and departed just as suddenly. An object later named Oumuamua. Unlike familiar comets, it behaved strangely. Its shape appeared unusual. Its motion difficult to explain completely. Subtle acceleration raised questions astronomers still debate today. Natural object? Exotic comet? Something stranger? The mystery lingered. Then came another visitor. The interstellar comet Borisov. More familiar in appearance. A glowing traveler wrapped in gas and dust, behaving more like something astronomers recognized. Yet even Borisov carried secrets. Its chemistry hinted at a birthplace unlike our own. A reminder that distant planetary systems may forge matter in unfamiliar ways. And now, another visitor has entered the story. A restless traveler drifting through our solar system. Faster. Stranger. More puzzling. An object astronomers have turned their attention toward with urgency and fascination. A messenger from beyond the Sun. Because unlike ordinary comets, interstellar objects carry something precious. Memory. Every grain of dust. Every frozen layer of ice. Every chemical signature acts like a time capsule preserving conditions from distant worlds we may never directly see. They are fragments of forgotten solar systems wandering through the galaxy. And when one enters our cosmic neighborhood, humanity listens. Powerful telescopes turn skyward. Spectrometers search for chemistry. Scientists race to decode clues before the traveler disappears forever. The challenge is simple. These visitors move fast. Incredibly fast. By the time we detect them, they are already passing through, spending only a brief moment near the Sun before vanishing back into interstellar darkness. A cosmic encounter measured in months. Then gone. Which is why every observation matters. Astronomers study brightness, motion, heat, composition, searching for answers hidden inside motion and ice. How old is it? Where did it come from? What forces shaped it? And perhaps most intriguingly, could objects like these carry ingredients essential to life? Because space is not empty. It is filled with chemistry. Carbon compounds. Frozen water. Organic molecules drifting silently across unimaginable distances. Some scientists believe interstellar travelers may help scatter life's ingredients between planetary systems. A provocative possibility known as panspermia. The idea that biology, or at least the chemistry necessary for it, may not begin independently on isolated worlds. Instead, the universe itself may distribute possibility. Fragments carrying ingredients from one system to another. Tiny couriers crossing the darkness. It sounds extraordinary. Yet even Earth may hold clues pointing toward cosmic chemistry older than our planet. And interstellar objects give us a rare opportunity. Instead of guessing what distant systems look like, we briefly hold pieces of them within observational reach. Imagine touching a rock that formed around another star. Ice frozen before Earth existed. Chemistry shaped beneath unfamiliar suns. A physical message written long before humanity emerged. That possibility alone transforms these travelers into scientific treasures. Yet every interstellar object also leaves behind mystery. Why do some behave unexpectedly? Why do their motions sometimes resist easy explanation? What hidden structures lie beneath frozen surfaces? Scientists remain cautious. The universe often surprises us for natural reasons. Cracks release trapped gas. Heat reshapes material. Rotations create unpredictable motion. Physics remains powerful even when unfamiliar. But uncertainty changes something. It invites deep, but mystery alone is not what makes interstellar visitors extraordinary. It is what they may be carrying. Because hidden beneath frozen crusts and drifting dust could lie something far more profound than rock or ice. A message written in chemistry. When astronomers study interstellar objects, they are not simply watching motion. They are reading history. Every wavelength of light reflected from an object contains clues. Tiny signatures revealing temperature, composition, molecular structure. Evidence of environments that no human being has ever seen. And what makes these travelers remarkable is this: they were not born here. Everything we know inside the solar system, Earth, Mars, comets, asteroids, formed from the same ancient cloud surrounding our young sun. Different worlds, yes. But part of one cosmic family. Interstellar visitors are different. They belong to somewhere else. Other stars. Other planetary systems. Other histories. Which means every fragment they carry becomes evidence of realities far beyond our own. A frozen archive drifting through darkness. Imagine chemistry shaved beneath a red dwarf star. Or inside a violent stellar nursery flooded with radiation. Imagine minerals forged in environments unlike anything in our solar system. Exotic ices. Strange carbon compounds. Patterns of chemistry shaped by alien conditions. This is why scientists react with such urgency when interstellar visitors appear. Because for a brief moment, humanity gains access to another star system without traveling there. And some of the implications stretch far beyond astronomy. For decades, scientists have explored a fascinating possibility. What if life's ingredients travel? Not organisms drifting intact across galaxies, but chemistry. Organic molecules. Carbon-rich compounds. Water-bearing minerals. The essential ingredients that make biology possible. This idea, known as Panspermia, proposes something extraordinary. Perhaps life is not isolated. Perhaps the universe shares its chemistry. Comets and interstellar debris crossing immense distances, scattering molecular building blocks from system to system like seeds carried by cosmic winds. If true, then worlds capable of life may inherit possibility long before life itself emerges. In this vision, planets are not isolated experiments. They are participants in a much older galactic story. Earth included. The atoms inside living organisms may carry histories older than our Sun. Older than Earth. Older than oceans themselves. And suddenly, interstellar visitors become something more than scientific curiosities. They become couriers. Travelers carrying fragments of forgotten environments across the galaxy. But chemistry is only part of the mystery. Motion tells another story. Because interstellar objects are rarely calm. Unlike planets locked in stable orbits, these travelers endure unimaginable violence. Close encounters with stars. Radiation. Collisions. Gravitational slingshots across cosmic distances. Frozen surfaces crack. Materials shift. Internal pressure builds. Sometimes unpredictably. Which is why strange motion does not automatically mean strange causes. A burst of trapped gas can change speed. A rotating body can wobble unexpectedly. Hidden fractures may redirect energy in ways difficult to predict. Astronomers know this. Science demands restraint. Curiosity guided by evidence. Yet mystery remains important. Because unexplained behavior forces better questions. Better instruments. Better theories. Sometimes confusion becomes discovery. Sometimes discomfort leads understanding forward. And perhaps that is the real lesson of interstellar visitors. Not certainty. Humility. Because humanity once imagined the solar system as isolated. Unique. Separate from everything else. Now we know the galaxy leaks into itself. Objects travel. Chemistry migrates. Fragments move endlessly between stars. The universe is not divided into sealed worlds. It is connected. A restless ocean of matter drifting through darkness. And somewhere right now, beyond the reach of our telescopes, countless interstellar travelers are moving silently between suns. Some may carry chemistry essential to biology. Some may preserve the memory of ancient planetary systems long destroyed. Some may already be crossing toward us. Invisible. Unnoticed. Waiting to briefly appear before disappearing again into the cold. Perhaps future generations will intercept one. Land on its frozen surface. Extract samples from material older than Earth itself. Read chemical histories written before humanity existed. Maybe they will discover something astonishing. New chemistry. Unexpected physics. Or evidence that life's ingredients are common across the galaxy. Until then, we watch. We measure.